Hello everyone, John Faulk here with JagSuccess, and today we're going to be covering the topic of antiderivatives as seen in Calculus 1. Let's take a look at some functions here. If we have anything in the form of a times x to the n, so let's see some examples like 3x to the fourth, or negative 5x to the negative 1. Actually, let's not do negative 1 right now. Let's do squared. Or 2x to the fifth. These are all in this form ax to the n. And we can do the antiderivative, which is also known as an indefinite integral. So, and these are seen as ax to the n dx, and this is going to be the same for antiderivatives. So to take this antiderivative, what we do is we leave a. This is going to be x to the n plus 1 over n plus 1, and then we're going to add on this plus c, and this c is just a constant, and we're going to leave it in that way. So let's take a look at these three examples that we have here. So if we have the integral of 3x to the fourth, we see that 3 is a and 4 is n. Let me add my dx here. So according to our rule, and this is called the power rule of antiderivatives, so if we look at this power rule, we see that a stays where it's at, and this is going to be x to the n plus 1, so that's 4 plus 1, which is 5, over n plus 1, which is 4 plus 1, which is 5. So we get this is 3/5 x to the fifth. And don't forget your plus c. And I'll tell you what this plus c is in a minute. So let's look at this negative 5x squared. So if we have the integral, or indefinite integral of negative 5x squared dx, we can do the indefinite integral, or also called the antiderivative. So a is negative 5. It includes both the negative and the 5. So we leave that alone. This is going to be x, and we see n is 2. So 2 plus 1 is 3. And then all over 2 plus 1, which is 3. And don't forget to add your plus c. Okay. So let's take a look at what indefinite integrals are, antiderivatives are actually doing. Because right now we're just applying a formula and seeing if it works, but we don't know actually what we're doing. So let's see what we're actually doing. Let's say we have a function 3x squared. Let's take the derivative of this 3x squared. So 2 times 3 is 6, and this is x. So this is the derivative. So what happens if we want to go from the derivative back to the original function? Well, that's when antiderivatives come into play. So let's take the indefinite integral of 6x, also known as the antiderivative. So 6 is a, so it remains the same. X to the n, so n is an understood 1. So 1 plus 1 is 2, over n plus 1, which is 1 plus 1, which is 2, which is 3x squared. But we also have this plus c. So we see we've taken 6x back to the original function, 3x squared. But we have this plus c. Now, what is this plus c? Let's do a case study. So we have 3x squared. Let's say we have another function, g of x, and this is 3x squared plus 2, and a third function, h of x, which is 3x squared minus 3. Now if we were to take the derivative of each one of these functions, something happens. They all become 6x. So all three of these functions, even though they're completely different, give us the same derivative. Now if we were to take the antiderivative from 6x back to these functions, you see they all have these constants. And this is an arbitrary plus 0. And that's what this plus c stands for. So when you take the antiderivative or indefinite integral of something, don't forget the plus c, because it's very important, because you are relating this back to not just one function, but a series of different functions that could actually happen. Alright, good luck.